Hello, and welcome to a quick standards update for busy BICSI professionals. Let's dive right in. We'll use three common project phases for cabling infrastructure to group the standards presented here today: design, procurement, and installation. When you're doing cabling infrastructure design, the TIA, and more recently BICSI, specify things like approved topologies, channel limits, spaces, pathways, and media types. Master format is the standard when it comes to organizing the vast volume of specifications and documentation associated with all phases of construction projects, including, of course, procurement. And when it comes to installation best practices and inspection guidelines, BICSI has its long-standing series of publications. Let's start with the standards associated with structured cabling design, which can be grouped in multiple ways. The first grouping highlights the core series of cabling standards from TIA, the TIA 568 series, currently in their fourth generation, as signified by the letter C. We've gone through B, A, and no letter at all. The C.0 applies to all types of buildings, so its recommendations are considered to be universal. It includes things like topology, as well as installation and test requirements. The C.1 focuses on the most common type of construction, the commercial building. In the past, this was the only type of building described, but as we'll see in a bit, things have changed considerably. The next three documents, .2, .3, and .4, describe the required performance characteristics of allowable media: balanced twisted pair, optical fiber, and broadband coax. And here they are in summary form. By the way, you can find this and the other summary slides you'll see in this presentation on the useful links page of our site, coreyandsteve.com. Feel free to use them however you like. Here's another way to look at structured cabling design standards, this time by type of building they cover. In recent years, TIA has expanded the scope of its standards beyond the commercial buildings that were the initial focus of standards efforts. We currently have published documents covering hospitals, data centers, factories, private homes, and coming soon we'll have specifications for schools. There's also talk of one or more initiatives to cover places where people assemble in significant numbers, such as indoor or outdoor spectator venues and houses of worship. And once again, here's the summary slide for standards by premise type. Our third grouping looks at design recommendations for things associated with cabling, which we'll place under the heading Common Infrastructure. First up is pathways and spaces, which deals with such things as adequate room and pathway sizing for all the cabling you're planning to put in there, both initially and over time. Next is grounding, which has both a mandatory safety and a recommended performance side to it. The electrical codes deal with the safety aspects of grounding, so unpleasant things like death and building fires can be avoided. The performance part covered by TIA attempts to prevent communication signal degradation due to undesirable noise produced by improper grounding. Safe is one thing, noisy is another. Administration deals with keeping track of things, which is not trivial when you're talking about a building full of cables, cords, and connectors constantly being accessed and frequently being modified without your knowledge. Outside plant guidelines are of interest to sites with multiple buildings that share communications infrastructure, such as campuses of one type or another. Finally, we have design guidelines for cabling things in buildings other than computers, phones, and wireless access points. The intelligent buildings being designed today are connecting everything, including the light fixtures, to the network and giving them IP addresses. So we need a standard to acknowledge and support building automation systems. And here's the summary of the 5 standards we group under the heading Common Infrastructure. The next 2 groupings are media-based. We'll start with fiber. In addition to the core 568C.3 document described earlier, we have a more recent addendum which adds OM4 fiber to the allowable types. And here are the standards for both OM4 and OM3 multimode, the most common types in use today. We also have the guidelines on testing for both multimode and single mode in the form of two 526 documents, 526-14-B for multimode and 526-7 for single mode. The TSB 172A bulletin is aimed at pushing the performance envelope for multimode fiber so it can continue to be used without channel distance penalties as bit rates increase. And once finalized, the TSB-4979 bulletin will cover consistency requirements for light sources found in optical fiber field test equipment. The last thing you want is for this tester to say pass and the other tester to say fail. So TIA is trying to make sure test results are as close to identical as possible when using multiple devices from the same or different manufacturers. We barely managed to fit all that onto a single slide, but here it is. Let's now move on to the copper side of things. On the left, we have the document that introduced Category 5E, and on the right is the guideline for testing installed older Category 5 cabling to see if it would perform to the levels specified in the newly introduced category. Here is nearly the same thing for Category 6. I say nearly because in the case of Cat 6, it's a little more narrow. We're not testing to see if Cat 6 will pass Cat 6A specs. We know it won't. Instead, we want to test the Cat 6 runs we have in our building to see which ones will support 10 gigabit Ethernet. If we're lucky, they all will, but at best over a channel no longer than 55 meters or 180 feet. And here's the document that defined Category 6A, or more formally, Augmented Category 6. In the future, we can look forward to Category 8, with an expected bandwidth of 2000 MHz, or 4 times the value for Category 6A. The goal is to support 40 gigabit Ethernet over twisted pair cabling, with a reduced channel length as low as 30 meters, or about 100 feet. So we're going from 100 meters to 100 feet, which is perfectly adequate for data centers and equipment rooms where 40 gigabit Ethernet connections are expected to be found. Oh, and please don't ask about Category 7. Let's just say that 7 is not a lucky number at the TIA, and leave it at that. Finishing things off is a document aimed at copper test set manufacturers to obtain consistency in the same way TSB 4979 is being developed for optical fiber test sets. And here's the summary slide for all things twisted pair. The last grouping is for the data center building type, which merits a closer look because of its influence within the structured cabling market. The data center infrastructure standards world is a bit more diverse than the TIA-only specifications described up to now. In addition to the TIA 942A document and its addendum on cabling guidelines for fabric switching, we have the very comprehensive BICSI 002 standard, the updated ASHRAE guidelines for thermal management, and the 4 availability tier classifications from the Uptime Institute. And since many organizations that operate data centers do so on a multinational or global basis, it's important to include the European equivalent to the TIA, which is CENELEC, as well as ISO IEC, which is a global reference source. And here they are as a group. Let's now move on from the design phase to the procurement phase with a look at master format. Since it is such an essential and near universal standard for all construction, master format is updated slowly and cautiously. The last major update was in 2004. To put that in perspective, prior significant updates were in 1995, 1978, and 1963. This chart and the one that follows illustrate the updates of significance to the structured cabling community. The 3 new divisions introduced in 2004 removed structured cabling from its previous position in the electrical division, then numbered Division 16. So 16 becomes 26, and 27 becomes the new communications division. In this chart, we also see the Level 2 detail for Division 27, so you can see where structured cabling fits in. We also have new divisions for the locks and surveillance folks in Division 28, and building management systems such as climate control and lighting are covered in the new Division 25. Our last stop takes us from procurement to installation, and here we feature the BICSI contributions in the form of standards publications and design manuals. This chart and the one that follows summarize the published and draft BICSI standards. You may recall that TIA also covered the types of facilities shown here, such as data centers and healthcare facilities. However, TIA tends to focus more on technical criteria for component and system performance, while BICSI's focus leans towards guidelines and best practices to ensure a successful deployment of the components and systems defined by the TIA. There are a few overlaps here and there, but you really need both sets of documents to get the whole picture. And in case you were wondering, no, I don't get a commission from either one. And to finish things off, this chart and the next list BICSI's design manuals, which are routinely updated to reflect advances in technology and best practices. BICSI has recently announced the retirement of their networking and wireless credentials. The grayed out manuals shown here served as the reference and study materials for those designations. That's it, we're done. And as mentioned earlier, feel free to pick up any or all of the summary slides from the useful links page on our site. We'll do our best to keep them as up to date as possible. Thanks for tuning in.